We're doing problem 29.57. We have a satellite, and it's orbiting the Earth at an altitude of 400 kilometers. That's right here. Maybe. Okay. And they tell us that it has an antenna that can be modeled as a 2.0 meter long rod. The antenna is oriented perpendicular to the Earth's surface, and we know that the Earth's magnetic field is essentially horizontal and has a value of 8 times 10 to the 5th Tesla. And they want us to find out what the induced EMF is. Well, we have an equation for that. E equals negative VBL. And we know so many things here. We know L, we know it's the 2 meters, and we know V, or B. We don't know V, okay? But they tell us all kinds of stuff that we need to know to find it out. Like it's orbiting the Earth, the equator, and its altitude is 400 kilometers. Oh my God, this just sounds like stuff that like we were supposed to remember from like stuff that's like orbiting the Earth successfully. So we're gonna have to do that. So something that orbits the Earth successfully, its gravitational force is its centripetal force. Yeah, that's where we're going. And this equation is G m1 m2 over r squared equals m1, because that's going to be the satellite, whose mass we don't know, I want to point out, b squared over r. That goes away, one of those. Okay. And this is this. V is going to be the square root of G m2 over r. Okay, that stuff we've done before, but it involves us looking up things. So we're going to have to solve that. Okay. So this is kind of a weird thing. But I want to point out, if you have to look at the mass of the Earth, which is 5.98 times 10 to the 24th kilograms. And the radius of the Earth is 6.38 times 10 to the 6th meters. Because remember, the satellite's above the Earth. If this is the Earth, it's up here. And so the radius is this whole distance here. So we're going to have to add those two things together. So this is going to be the constant. It's going to be 6.67 times 10 to the negative 11 newtons meter squared over kilograms squared times the mass of the Earth, 5.98 times 10 to the 24th kilograms, all divided by the radius, which is 6.38 times 10 to the 6th plus, it says 400 kilometers, so it's going to be 400,000 meters. So now we have to actually calculate what that is. So I'm going to take my calculator and do exactly that, no more, no less. So 6.67 times 10 to the 11th times 5.98 times 10 to the 24th divided by 6.38 times 10 to the 6th plus 400,000. I get an answer that I take the square root of, and I got a speed of 7,670 meters per second. Now I can go back over here and actually solve for what that is. And again, so I'm going to get 7,670 meters per second. 8 times 10 to the negative 5th Tesla, and 2 meters. So let's multiply all that stuff together. Times 8 times 10 to the negative 5th times 2. And I get a voltage of a staggering 1.23 volts. So again, that's like not even like a AA battery. So it's not going to do me a ton of good, but hey, it's better than nothing.